Hello again, guys. So this is the video for question number 12 in the AP packet. So if we take a look at this one says two runners, A and B, run on a straight racetrack from 0 to 10 seconds. The graph above, or in this case to the right, consists of two line segments that shows the velocity in meters per second of runner A. The velocity in meters per second of runner B is given by the function v, defined by v of t equals 24t over 2t plus 3. Okay, in A, find the velocity of the runner at find the velocity of runner A and the velocity of runner B at t equals 2. Indicate units of measure. Okay, so here we go with this one. For runner A, we want to find the velocity at 2. Now, if you take a look at the graph, this is the velocity graph, so we want to find the velocity at 2. Now, you could eyeball it, but that's not pretty much a good idea. I would not recommend that because we don't know for sure what the value would be. So what I would do is I would want to come up with equation of this line segment to figure out what the acceleration is. So if you take a look at this graph, we want to find out the slope, so we can figure out the equation of the line. So the line would be in the form of y equals mx plus b. I understand that this is not a function of x, it's a function of t, but we just need to get a quick line out of this. So we know that our v of t is going to be my slope, which I don't know yet, times my x, which is going to be t, and the y-intercept is going to be 0. All right, slope. So it's the change in my y over my change in my x. So the change in the y is 10, and the change in the x is 3. So we would say the slope is up 10 over 3. So my velocity function is 10/3 t. So if I wanted to find out what the velocity is at 2, it would just be 10/3 times 2, which would end up being 20/3. And then as far as units of measure goes, it would be measured in meters per second. For runner B, we want to find out what the velocity is at 2. So velocity at 2 for runner B. So I'm going to do runner A and runner B just to clarify the difference of those two guys right there. So I'm just going to plug in 2 in for my t value. So we have 24 times 2 over 2 times 2 plus 3. So we end up getting 48 over 4 plus 3. So we get 48 over 7. And then this would also be measured in meters per second. Okay. So again, just to recap, we have the velocity of runner A. We had to find out what the equation of this line was. So we have the equation of the line is 10/3 t. We're going to use the t value of 2 to plug in, and then we get 20 over 3 meters per second. Runner B, just plug in 2 into my velocity that was given to us already, and then evaluate, and then we get 48 over 7, again, meters per second. All right, for B, the acceleration of runner A and the acceleration of runner B at t equals 2. Indicate units of measure. Okay, so we kind of already figured out what the slope is. So for runner A, we know that the derivative of the velocity function is actually the acceleration function. So if I want to find out what the acceleration was of runner A at t equals 2, it'd be the same as the derivative of the velocity of runner A at t equals 2. So if I do that, we know that from the line, we'd end up just getting 10 over 3. And then as far as units of measure go, it'd be meters per second squared. Okay, for the next one, runner B. We would have to use the derivative of runner B to get the acceleration of runner B. Okay, so the way we're going to do that is the acceleration of runner B at t equals 2 is equal to the derivative of runner B at 2. Now, since this is a calculator question, I already put this into my calculator. It's into my y equals, just so you see it right here. And then what I'm going to do is I'm going to do my math 8. So I do the derivative, and I want the derivative of y1, and I want the derivative of y1 at t equals 2. And there we go. So we end up getting 1.469. And it'd be measured in meters per second squared as well. Okay, last but not least, so we have C. It says, what is the total, find the total distance from the runner A and the total distance of runner B over the time interval from 0 to 10, indicate units of measure. Total distance is total distance traveled. So we know what that is. So for total distance traveled of runner A, we're going to do the integral from 0 to 10 of the absolute value of the velocity of runner A dt. So now, of course, they didn't give us an equation here. So in other words, remember, again, the most important thing is that when we see integral, when I say integral, you should all be thinking area. So we need to find the area under the curve from 0 to 10. Now, it's entirely above the x-axis, so we don't have to worry about the velocity's absolute value because it's going to be positive anyway. So what I'm going to do is, it looks like you could look at it as a trapezoid. So it's going to be the area is 1/2 the base, or 1/2 the height rather. So the height is 10 times base 1 plus base 2. So base 1 is 10. That's this measurement all the way across. So this is base 1. And this right here is base 2. So it's going from 3 to 10. So that'd be 7. So we'd end up getting here 17 times 10 is 170 divided by 2. So again, 170 divided by 2. So the distance traveled would be 85, and then it would be measured in meters. So 85 meters. Okay, so that should be for runner A, the total distance traveled of runner A. So now let's do runner B. Okay, so again, it's going to be the integral from 0 to 10 of the absolute value of the velocity of runner B. Okay, so this one we're going to put right into the calculator as is, since it was algebraically defined. So what I'm going to do is I'm going to do math 9. I'm going to do the integral from 0 to 10, because that's what the question did say. If you look at it, it did say from 0 to 10 after all. Just want to make sure I'm clarifying that. And then I'm going to do vars. Oh, wait, hold on. Before I do that, I have to put the absolute value bar in, because it is, after all, total distance traveled. Vars, y vars, function y1. And then, no, you don't go there. You go over here. Okay, so for this one, there we go. We got 83.336. And this would also be measured in meters. And this would give me the total distance traveled by the second runner, runner B. So again, to recap on this one, total distance traveled, remember you have to do the integral of the absolute value. I'm not using my initial condition on this. I don't think there even was an initial condition, so we're good. For runner A, you'd have to approach the problem graphically by finding the area under the curve. Since it's entirely positive, we don't have to worry about any negative quantities, so we're good with that one. And then with this one, we use the calculator to get our answer. All right, stay tuned for the next video. That will be question number 13.